And good evening, everybody, and welcome to this Sigma meeting for March 2024. My name's Pete Sherman. I'm the chairman of Sigma. I'll be your host for the evening. I'd like to start by welcoming all the Sigma members and also all our affiliated club members too. Let's say the Highland Astronomical Society, Aberdeen Astronomical Society, Caithness, and Dundee. We have a couple of them here tonight as well. And of course, any first-time visitors, and a special warm welcome to all our new members that have joined over the last couple of weeks as well. We're all very welcome, and welcome to Sigma. Helping in the background as usual, we've got Rich and Mick, who are the Zoom co-hosts, so should I drop out for any reason, they'll take over and keep things running smoothly. And also we've got Chris, who's handling the Q&As, and I'll explain in a few moments just how to ask your questions to our speaker tonight. So we've probably got a couple of new people here who have not used Zoom in the past. If you want to ask any questions to our speakers, you'll see there's a little toolbar pops up, the Zoom toolbar, and there's a Q&A button. If you, at any time throughout the talks, you can actually click that and type your questions into there, and then Chris will keep an eye on those and ask them over to Ian at the end of his talk. Okay, if you've got any issues at all, there's a little raise hand button. You can click that at any time, and one of us here on the panel will notice that the hand's up, and we'll contact you through the chat and see what your issues is. But we've not had any issues the last few weeks, few months, so I think everyone should be okay. Okay, the meet and brief, the way it works. So we have the main talk, that'll be from Professor Ian Robson tonight. And then as I say, Chris will handle Q&A. We then still have our little 10-minute break, just to give us a chance to get set up for the second half. And then in the second half, after the break, we have the members' photos, and there's quite a few of them come through this month. We must have had some clear skies. In the last couple of nights, we've had some pretty good seeing. Then Mick will be doing the morning sky at night to show you what can be seen over the coming month, until we start to lose the night time and end up having too much daylight again. It's a double-edged sword, that. Sometimes it's, I think we haven't seen the sun for long enough. We need a bit of daylight now anyway. And then to finish the night off, there'll be me giving you a little bit of club news that's going on. Okay. So tonight it gives me great pleasure to welcome back to Sigma for the third time, Professor Ian Robson. He's joining us tonight from his home down in Preston. Ian was last with us in July 2018 with his talk on Confessions of an Astronomer. I remember it well. Professor Robson has been the head of the physics and astronomy at UCLan, director of the James Clerk Maxwell Telescope in Hawaii, director of the UK Astronomy Technology Centre at the Royal Observatory in Edinburgh, and director of the Science and Technology Facility Council's Technology Department. He has undertaken extensive research in the field of active galaxies and submillimeter astronomy, and wrote an undergraduate textbook on active galaxy nuclei. Professor Robson is very active in outreach and was the first president of the International Astronomical Union, the IAU, Commission for Communicating Astronomy to the Wider Public. He led the UK programme for the International Year of Astronomy in 2009. Funny little thing now, I was around at Rich's tonight going through a few things, looking for some stuff for some outreach, and I found all the stuff that was still there from the event we did in 2009 for that. It's still there. So Ian, he was the IAU Assistant General Secretary for 2018 to 2019, and has been president of the Society for Popular Astronomy and the Royal Scottish Society for the Arts. He was vice president of the Royal Astronomical Society from 2021 to 2023, and received the RSA Service Award in 2024. And I can see the reason why you've got that award, Ian, for all that hard work you've obviously done over the years. So everyone, it gives me great pleasure to welcome for the third time to Sigma, Professor Ian Robson. Ian, if I could turn your camera on. And your microphone. There we go.
Here we go. I'm going to share screen.
Yep, I'll let you know if it's working okay. We've got that. it's over to you.
Okay, I'm just moving various taskbars out of the way so they get the...
Okay. Oh, you've muted yourself, Ian.
Is that
That's better.
gone? Oh,
Yep.
good. Everything's looking
can...
fine now on the screen.
Okay.
That's great.
Over to you then.
Well, hello, everyone. It's great to be back talking to Sigma. And wish I wasn't up there in person. That would be really, really good. And first thing, a confession. A number of you will realize that I'm not a planetary astronomer or a solar system astronomer. My field of research is active galactic nuclei and submillimeter. However, this is an interesting story that I sort of lived through as my life as a professional astronomer. And it also tells you a bit about how science actually functions and how science evolves. So here we go with the Pluto story. And it's not about the dog. Although, as you'll see later at the end, the dog does come into the story. You can't just prevent it. So let's start at the beginning. Naked eye planets in the solar system, we know we have 5 of those, known it forever. And then we had the first telescopic discovery of a new planet, Uranus, discovered by William Herschel, 1781, had been seen before, but the telescopic observations proved it was a planet. As astronomers monitored Uranus in the sky and tried to plot out its orbit, they realized that Uranus's orbit wasn't following Kepler's laws, and it looked like it was being perturbed. Perturbed by what? Perturbed by something else out there, another planet, and a massive planet at that. Then people started calculating what this unknown hidden body could be. And Adams in the UK and Leverrier in France both calculated the position of the new planet. And Leverrier published his observations, and almost immediately Neptune was discovered. Very, very amazing set of calculations indeed. So now we had 2 more planets. But there was still some debate about the orbit of Uranus and the possibility there was still another planet out there, Planet X. And so this was in the thing. But I think you have to realize at the very beginning that there hadn't been a lot of time to actually calculate the length of the orbit. So the calculations were based on a slightly short bit of orbit of Uranus. So Percival Lowell, who was the director of the Lowell Observatory, he'd searched for Planet X from 1906 until he died in 1915. And then his wife, who was called Constance, she tried to get hold of all the data and carry on the search. But there was a legal impasse with the essentially governing body of the observatory. And it took her a while before she got access to the data. Eventually she did, and the search resumed in 1929. And she hired a young amateur astronomer engineer, Clyde Tombaugh, and he used a magic device called a blink comparator, which I will talk about in a moment. And in no time at all, in a few months, he discovered Planet X in January, February 1930. But there's always a suspicion amongst many people, was this just by chance? It certainly wasn't based on essentially calculations like that had been done for Neptune. And so this is Clyde with his own amateur Newtonian telescope. This is a blink comparator. This is a magic device. And it works by essentially having 2 photographic negatives, photographic plates, looking at exactly the same piece of sky. And in here, there's a flip mirror and an eyepiece. So you look through the eyepiece, you see the flip mirror here, and it flips between this image and this image. And because we have exactly the same piece of sky, but a few nights apart, if anything has moved, the eye-brain combination is very, very good at picking this up quite easily. And so this was the discovery of planet Pluto. You can see the little dot here on the left-hand image, which has moved to the dot here on the right-hand image. And in fact, when people started looking at the archives, they realized Pluto had been seen many times before, but just never recognized as a planet. And so this is how the blink comparator works. If you look at this and I blink between them, then in the center of the image, you can just about see 2 stars change. It helps when I put the arrows there. That's cheating. So now we come to the naming of Pluto. And in those days, the Lowell Observatory, the discoverer of the planet, they had the naming rights. and they got over 1,100 suggestions, and they boiled it down to a short list of 3 names for the staff to vote on. This was Minerva, Kronos, and Pluto. Pluto, funny enough, was proposed by an 11-year-old Oxford schoolgirl, Venetia Burney, although she didn't do it directly. She told her father, who told her his father, her grandfather, who told the head of the Department of Physics at Oxford University, who then passed it on to the Lowell Observatory. And then Pluto was the unanimous choice, Roman god of the underworld. And so what do we know about Pluto? Well, key parameters about any new object you're looking at in the solar system. You want to know how big it is, how heavy it is, and what its orbit looks like. So let's begin with the mass. In 1931, the estimate was the effect on the orbit of Neptune and Uranus must be around Earth mass. It must be quite significant. But that was based on not a lot of data on the orbits. In 1948, Gerard Kuiper, he claimed that it had a diameter which gave it about 10% of the Earth mass, something like Mars. But this is a bit of a cheeky observation, really. In 1976, big progress was made. Dale Cruikshank et al. From the University of Hawaii, they measured the albedo, that's the reflectivity of the surface of the atmosphere, and they found it was methane ice. So the thing actually looks very, very bright for its size, which actually means it's smaller than you think it is. So the mass is only 1% of the Earth. So Pluto is shrinking all the time. Then in 1978, discovery of the moon Charon, the ferryman over the Styx in Greek mythology. They then found out that the orbit then gave it only 0.02% of the mass of the Earth. So Pluto is getting really, really very light. And there are lots of people having doubts about this. Really could be Planet X. So even from the very beginning, Pluto was in some danger. And this is the only graph I will talk about tonight. On the y-axis, this is Pluto's estimated mass in Earth masses, going from 10 Earth masses at the top to 1 to essentially nothing, plotted against the year. And you see when Pluto was discovered, it was a few Earth masses, and then it went down to essentially nothing. And if you keep the graph going, it should have vanished altogether by now. And with better calculation of the orbits of Uranus and Neptune, the reason for even having a Pluto essentially goes away. And with the Voyager probes, which get very, very accurate distances and orbital parameters, the reason for having a Pluto had vanished. So an interesting discovery, which you might think was really quite a fluke altogether. Okay, let's move on to Pluto's size. This is very hard to determine because it's too small to measure directly, and we didn't really know this until very recently indeed. You can make estimates, you can always guess these things, but you've got 3 parameters of the albedo, that's the atmosphere, which was essentially calculated, but then you have to guess the density if you know the mass. That'll give you the size, or vice versa. If you know the size, you can get the mass. So it's tricky, but the best estimate now comes from direct measurements of the New Horizons mission to Pluto, which we'll talk about towards the end, is 2,374 kilometers. And for those of you who are up to things in the solar system and know about these, this is actually very small compared to the other planets. Now, I must admit, when this was all going on, I really was not well adapted knowing the size of bodies in the solar system. So just to remind ourselves, this is the Earth, our moon, and Pluto. Pluto is significantly smaller than the moon. And if you look at satellites in the solar system, we have the Galilean satellites of Ganymede, Titan, Io, and Europa. Callisto, Io, and Europa. Then we have Titan for Saturn and Triton for Neptune. Our moon fits in there quite nicely. Pluto is really quite small, given the fact it's meant to be a planet. But also, Mercury is not very big either. Mercury only just fits in there, which I think is always interesting to bear in mind. Mercury is not a big planet. It's a tiny planet. Let's look at Pluto's orbit. Now, you have to realize that most of the planets in the solar system have essentially got flat orbital planes. They all go around in one plane, more or less, within a few degrees of the same plane. They also more or less go around in circular orbits. None of them have a reasonably high eccentricity. Pluto is 40 times farther away from the sun than is the Earth, period of 248 years. But the two things that really make it stand out, the eccentricity, i.e. how much it departs from a perfect circle. The eccentricity is 0.25, so it's really quite elongated. And the inclination, how the orbit is tilted to the rest of the plane of the solar system, is 17 degrees. This is widely different to anything else, any other planet in the solar system. And this gives us an example now. We can see Pluto is highly inclined and highly elliptical, and everything else essentially is circular and in one plane. Then we can ask, well, if Pluto is different to the other planets, is it similar to anything else? And the answer is yes, it certainly is. It's very similar to the Kuiper Belt. Proposed this was in 1943 and 1951. This was maybe a regime of small bodies, reservoir perhaps for comets or centaurs, outside the solar system, way beyond where Pluto was. Nobody had ever seen anything from there, but it had been predicted to exist, and maybe reservoir for the comets coming in. Now, in 1992, this was a big breakthrough. Dave Jewett and Jane Lutu from the University of Hawaii in Honolulu, they discovered the first Kuiper Belt object, called KBO, and they called this Albion. And now there's more than 3,000 of these Kuiper Belt objects discovered. This is just the tip of the iceberg. When we have bigger telescopes like the Vera Rubin telescope, we're going to discover thousands more of these. So what do we know about Kuiper Belt objects? Well, they come in various forms, and astronomers love to classify things. They can be either cold, circular with non-inclined orbits, like the planets, hot, elliptical and inclined orbits, like Pluto, resonance, orbit locking with Neptune, also like Pluto, which happens to be in a 3-2 resonance locking with Neptune. Or they could be scattered. They come in, they pass Neptune in close approach, they get scattered out into a much more elliptical orbit. Another name for these things is trans-Neptunian objects, or TNOs, and I'll use TNOs and KBOs willy-nilly throughout the talk. So this is an example, and you see Pluto is the magenta orbit here. Then we have Eris, which has got a much more elongated orbit. Then we have Sedna, which has got a hugely elongated orbit. And then another elongated orbit. So these things are very different. These are other, essentially, Kuiper Belt objects, which we won't worry about. And this is the various names and estimate sizes of these things. And many of them have Hawaiian names because they were discovered by the University of Hawaii. So what did the impact have for Pluto on these Kuiper Belt object discoveries? Well, in 1978, Pluto discovered to have a big moon going around it. And it was a big moon, much bigger than anything else in the solar system compared to the size of Pluto. So this was an oddity. And by the mid-1990s, the planetary status of Pluto was certainly being questioned by others like Dave Jewett. And I remember when I was in Hawaii, he came across in the mid-90s to give a seminar about Kuiper Belt objects, all the new ones that have been discovered. And at the end of the seminar, it was quite obvious that, you know, for most people in the audience, Pluto was really just a Kuiper Belt object. It was just a big Kuiper Belt object, but that's what it was. It just looked like everything else. So then there's a proposal to the International Astronomical Union in 1999 to reclassify Pluto, to essentially deplanetarize it. This was the IAU General Assembly was going to be held in Manchester, but the organizing bodies in the General Assembly took one look at this and said, no, we're not going to touch this with a red hot poker. Go away. And then in 2000, Neil deGrasse Tyson, the American Museum of Natural History and the Hayden Planetarium had a renovation. And so Neil deGrasse Tyson took all the planets down, then he rehung them back up again, omitting Pluto. And this caused real hate mail and angst and a lot of negativity from school children who would go to the museum and say they've got it wrong. So I think people realize that if you're going to take Pluto from being a planet to something different, you might have a problem here. And then in 2003, the situation got even worse because Eris TNO or a KBO was discovered by Mike Brown, who was a famous Caltech planetary astronomer, good observer. This was thought to be bigger than Pluto. So does this mean Eris was the 10th planet? Then it got worse because in the same year, Sedna had been discovered. And Sedna was also looking like it was about as big or bigger than Pluto. So was this the 11th planet in the solar system? So things were getting real murky by 2003. This is the only image that we have from essentially the orbit of the Earth. This is an HST, a Hubble Space Telescope image using a faint object camera. And you can certainly see Pluto and Charon with a wide separation between them, but that's about all you can really see on them. Let's now move to the International Astronomical Union, the IAU. This is founded in 1919, so it just had its 100th, it's just in its centenary. It's the largest body for professional astronomers with about 10,000 members, depending upon how you count it. It could be 13,000. It has a great mission to promote and safeguard the science of astronomy in all its aspects through international cooperation. It now also is the internationally recognized body for assigning designations to naming things, surface features, rivers, everything else there. It gets to name things. What else does it do? It holds a General Assembly every 3 years, which is a big astronomical conference focusing on many different subjects, as well as what's called business meetings, which focus on the politics of essentially professional astronomy. So it's one of the most diverse astronomical meetings, and it usually has many hundreds of astronomers present. So the IAU realized there was going to be a problem coming here. So in 2003, they realized that in 2006, the General Assembly was going to be held at Prague in the summer, in August. And so they thought that they really had to sort out Pluto and to come forward with some reservation for it. So they, like every good organization they set up a committee. This was the Planet Definition Committee set up. And the Planet Definition Committee was asked to come up with how do you define a planet, which we'll get to in a moment. But, and this is where the IAU slipped up, they already had a planetary system sciences group, which was called Division 3. And these people definitely would have their say. Now, I should explain that there are many divisions. I think there are about 13 divisions altogether. Divisions on essentially active galactic nuclei, black holes, gravity, quantum mechanics, exoplanets. So they all have their specialist divisions, and Division 3 specialized in planetary dynamic systems and the solar system. So in some respects, without contacting Planet Division 3, the IAU executive had essentially put themselves under a plot of disaster. So they were given a charge, which is a regulation to come out with an answer. And this was very good, really. So one, discussing the broader social implications of any new definition of a planet and recommending a course of action that balances the scientific facts with the need for social acceptance of any change. And two, addressing the status of Pluto in particular and of the newly discovered TNOs in the light of recommendation 1, then considering whether the current naming procedures for planets and minor planets have exacerbated the problem of defining a planet and recommending whether divisions are needed. And finally, attempting to frame these recommendations as a resolution or resolutions that could be put before the business meetings of the Prague General Assembly in August 2006 for possible adoption. So this is a very legalistic way of saying this is what they had to go away and do and figure out how to define a planet and come back with some resolutions. So Ron Akers, who was the IAU president and a very famous Australian radio astronomer, he said and wrote, "From time to time, the IAU makes recommendations on issues concerning astronomical matters affecting other sciences or the public. Hence, IAU recommendations should rest on well-established scientific facts and have a broad consensus in the astronomical community." And that was a very sensible statement, recognizing the fact that you've got to get this right, otherwise there could be mayhem going on. The Planet Definition Committee thought actually they were going to have a hard task. It was going to be difficult. And it turned out after one day, they thought they'd cracked it. And their answer was, a planet is a celestial body that A, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, round shape. In other words, it's big enough and heavy enough so it becomes round. And B, is in orbit around a star, but is neither a star nor a satellite of a planet. So it's going to be big enough for its gravity, self-gravity, to pull it into a nearly spherical shape. So that seemed okay, except it was going to cause severe problems. Now, the IAU appreciated this was going to have a negative impact or a potential negative impact. So they appointed a press officer 6 months before the General Assembly. They'd never had one before, but they realized they really had to have someone to deal with the press and all the communications and the comms. And this is where I got more involved with the Pluto story, because at the time I was president of Commission 55, communicating astronomy with the public. And I had a vice president and a secretary. And the secretary turned out to be the press officer who'd been appointed for the IAU. So the General Assembly in Prague was August the 14th to 25th. And August the 13th was a Saturday, the day after the attempted bombing on planes, where you couldn't take any liquids on board anything, and all you could take on board a plane was a small plastic bag with your passport in it. So that was the day we all remember trying to get there with laptops in suitcases and hoping it didn't get broken. Now, on the Sunday, on the 14th, I was shown an embargoed press release for the 15th, and my colleague brought this A4 piece of paper and said, this is it. This is the press release that's going to be issued. This is what the executive have agreed, the definition of a planet and the outcome for Pluto. And I just looked at this and just thought, it's just never going to work. You know, you get these feelings. You've been around the block a number of times. You just look at a piece of paper and you say, nope, it's just not going to flow. It's not going to run at all. So their proposal from the IU Executive Committee was there were 12 planets in the solar system, with potentially more to come as they were discovered. There were 8 planets that dominate the system, 4 planets in a new and growing category of Plutons, Pluto-like objects, and this includes Pluto and Charon as a binary Pluto-like object, Eris, the TNO, and Ceres, the big round asteroid. Now, interestingly enough, when Ceres had been discovered in about 1800, it had been classified as a planet. But as more asteroids were discovered, then by 1850 it got negated to become just one of the asteroids, or the biggest asteroid in that. So this was their proposal. We're going to have 12 planets, but actually there could be more to come. And I just thought this is never going to work at all. And so this is what essentially the artist's impression came out with. And I think this is a fabulous diagram. And for those, everybody's on Zoom tonight, so you'll be able to see it high resolution. This is the planetary system to scale of size, clearly not distance, but scale of size. And you see tiny Mercury, and you can just about see Ceres as a pixel, and then Pluto and Charon, and then Sedna at the very far end, or Eris, at the very, very far end. So this is the solar system, and you'll see this comes back again, but it's a beautiful diagram altogether. So the IAU, they put a lot of effort into this because they knew what the potential impact might be. So there was a major effort to keep the press like on side, at least to ensure the press reported the transparent and open process of clearly scientific debate. And this is what it had to be, scientific debate, not emotional debate. They had lots of information on the web. They had question and answer links for the press. They had sheets of information, and they put a lot of work into this. This was the press room. This gentleman here on the left is Owen Gingerich, who was head of the planetary definition group, who sadly died just last year. But a lot of information went in there, and essentially we're in for it. So what happened at the General Assembly in Prague? Well, the first plenary meeting, which was on the Monday, showed this was going to be very contentious. A plenary meeting is where everybody gets in a big auditorium and discusses the business meetings that's coming up, and there might be 1 or 2 invited talks in general. These are not the specialism discussions. And it showed it was going to be very contentious. There were people who were for Pluto being a planet, people who were against Pluto being a planet. Nobody liked the executive definitions of what they come up with. 12 planets, more to come. And so I thought this is going to be really exciting. So on the 18th, instead of going to my Active Galaxies and Black Holes conference meeting, I went to the Planetary Sciences Division 3 meeting. And it was absolutely packed. There was standing room only, but I got there nice and early, so I had a good seat. And it was fascinating. There were essentially eminent astronomers who I didn't know, but who'd spent their lives essentially calculating planetary dynamics, orbital dynamics, things that I'd really not heard of at all. And they were all very unhappy about Pluto and Charon being a double planet. This is going to be unique in the solar system, and that they didn't like that idea at all. And then they had major disagreements about the definition of a planet from the planetary definition group. And Division 3 wanted a further point to be added, and they were absolutely adamant about this. But it was something I never heard of before. The planet, to be a planet, must have cleared its orbit. And I'd never, ever heard of that before, but it became a really contentious and critical point of view. So a counter-proposal was immediately mounted against demoting Pluto. This was led by Alan Stern from the New Horizons NASA mission. And he got an email petition together in a space of a few days, which had 200 names on it, which was a good attempt altogether, really. And people said, well, hang on. If clearing of the orbit, doesn't that rule out Neptune being a planet? But the answer was from Division 3, no, it's all about resonances, which we will come back to in a moment. Then the same thing, well, what about Jupiter and the Trojan asteroids? Surely that means Jupiter's not a planet either. And the answer was, no, it's all about resonance again, and Lagrangian points, which are horrible mathematical things in orbits. And here we have a complicated diagram, which is really quite simple. If you look at the yellow thing in the middle, assume that's the sun. Then the blue blob at the right, that can be the Earth or it can be Jupiter. Let's call it the Earth for the moment. Then we have these various points, L1, L2, L3, L4, and L5. These are what's called Lagrangian points. And the interesting thing about these is just the way the gravity works. But if you put a body at around about one of these Lagrangian points, it will stay where it is. You don't have to use energy to keep it there. If you put a body anywhere else, you have to use energy to maintain that orbital parameter. So you'll recognize L2 these days, because L2 is where satellites go if they want to go to a stationary point where they don't have to use essentially any fuel, and they can stay there for a long time. The Gaia satellite went to L2, it's about 1 million miles away. And of course, more recently, the James Webb Space Telescope went to L2. So Lagrangian points are well known, and they're all built on resonances, and it's very complicated. Now, here we have the Trojan asteroids, and here we have the inner planets, and here we have Jupiter, and we have all these Trojan asteroids, and they sit at the Lagrangian points. They don't stay where they are exactly, but they don't move around the orbits. They don't come to here. They stay essentially in the same location. So it's not like the Lagrangian points are point-like. They're zones. So that the planetary dynamicists explained the resonances and said, that's why Jupiter's a planet, that's why Neptune's a planet. So no worries. And in fact, we have now sent a mission to go and look at the Trojan asteroids. It was called Lucy. It was launched in October 2021. It will arrive in 2027. Then it'll come back. It's going to go to visit these lot first, the advancing asteroids. It's going to go and do a flyby of one of these. Then it's going to come back to the Earth, do a quick zip of 1 or 2 flybys to give gravitational assist, and then get back out to do the trailing asteroids in 2033. And recently, it's whizzed past an asteroid in the normal asteroid belt, which isn't actually shown on this diagram. So the next Division 3 session was on the 22nd. And this was a very stormy Division 3 session. And because it was obviously not going to fit into a room, it had been moved to the main auditorium. So everyone was in there and everyone joined in. And It was real mayhem. There were lots of very passionate speeches, both for and against. Resolutions were being made, changed, amended in real time. The chairman was losing control and also was being accused of being biased. And of course he was, because he was part of the executive who proposed 12 planets with more to come. And he was really getting quite angry altogether. So the final plenary session was on the 24th, which is the Friday. And this is the time that they had to have the vote. And it was in the plenary hall, lots of comments and still confusion about the status of Charon. And it was a packed session, but unfortunately, I'd had to leave to go back to Edinburgh, so I had a very important meeting. So nevertheless, I was logged on to the ESO video channel, which was broadcasting it in real time. And my vice president from Commission 55 was in the audience with a cell phone, and he had that open, dialed into me and telling me about exactly what was going on. So it was real fun. And Jocelyn Bell Burnell, who was on the one of the panels, she took charge and chaired the session, and she was absolutely brilliant. She really was great. And she calmed it down enormously from being very, very bitchy to essentially a calmer atmosphere of passionate arguments for and against. And she had her props here. And I asked her afterwards, what were the props? And clearly Pluto, the dog, is there. The serial was meant to be Ceres. The planets was the umbrella of planets in the solar system. And she can't remember what the blue balloon was for, but she thinks it might be Neptune. But she did a brilliant job in terms of organizing it and taking amendments and things like that. And that was excellent. So then we eventually had the final resolution. And I'll read all these out in careful slowness. The IAU therefore resolves the planets and other bodies in our solar system, except satellites, be defined into 3 distinct categories in the following way. So this is how we're going to define planets from now on. A planet is a celestial body that A, is in orbit around the sun, we'll tick the box there. B, has sufficient mass for its self-gravity to overcome rigid body forces, so that it assumes a hydrostatic equilibrium shape, brackets is nearly round, same as before, tick. But C has cleared the neighborhood around its orbit. So Division 3 had got their way in terms of the final resolution. Secondly, we define a dwarf planet. And this is where I thought it was way over the top. I thought, why not just call them Kuiper Belt Objects or TNOs, or why define this dwarf planet thing? Anyway, this is what came out. A dwarf planet is a celestial body that A, is in orbit around the sun, same as before. B, sufficient mass, etc., 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 is nearly round, big enough, tick box. But C has not cleared the neighborhood around its orbit, and D is not a satellite. In other words, it's big and round, but hasn't cleared the orbit. All other objects, except satellites, orbiting the sun shall be referred to collectively as small solar system bodies. So asteroids, comets, all get lumped into this in the columns, and TNOs and KBOs, small solar system bodies. So I thought 2 and 3 were just total cop-outs, but that was just my personal view. And then, of course, we had to have amendments. 1, insert the word classical before the word planet. This is the amendment 1. And 2, the IU further resolves Pluto is a dwarf planet by the above definition and is recognized as the prototype of a new category of trans-Neptunian objects. So this at least links dwarf planets with TNOs. And the following sentence is added, this category is to be called Plutonian objects. So we had to vote on all of these things in terms of the debate. This is the auditorium, and there's Jocelyn on stage. And you had to hold up a piece of yellow paper, which you were given when you went in, so the tellers could actually go around and count if they thought the vote was essentially going to be close. So the results were, the resolution was passed with overwhelming majority from the audience, show of hands. So tick box, everything is great. The First Amendment, 91 votes in favor, but overwhelming show of hands against, which was adding the word classical. So that's gone. Second Amendment passed, and I had to count this one, 237 for 157 against. Pluto is a dwarf planet and the new TNOs, etc. So that was better. Third amendments failed with 183 versus 183 against Plutonian objects. And from my experience of these votes, that's a dead heat. And if you took the vote 5 times, you get 5 different answers, I'm sure. So what happened then? Big negative reaction from the public. This big emotional connection with Disney's Pluto and the dog, and particularly from the Americas, North America and South America. Big emotional connection. And then the scientific criticism. This was totally non-democratic. There was only 5% of the world astronomers who had voted. Only about 400 members were there, so that's done. Lots of negativity from the US. They said it was all partisan, and the New Horizons team members were absolutely aghast. Their mission to go to the outermost planet, which all of a sudden is no longer the outermost planet. So they were not happy one little bit. And there was a wide range of press coverage, which we'll talk about next. And so the New York Times, so what is a planet? The debate continues. And this, in fact, was actually very good for astronomy and very good for science, because the press, certainly the professional press, took this very seriously. And there were some excellent articles about how science evolves and what's about the debate about a planet. Nature editorial, round objects. That's what it's all based on. And then the New Scientist, down but not out. The decision to relegate Pluto from a planet to a dwarf planet was a wrench for astronomers, but there's no need for a tearful farewell, and a great cartoon of poor Pluto being exited from the family of planets. And then Nature, the major journal, Pluto, the backlash begins. And this essentially is picking up the American criticism of the orbital dynamics and things like that. And then Science in America. Again, the beautiful diagram I showed you before of cosmic proportions, and a long discussion about this in general. So some very, very good press coverage. This is the German Meinung opinion. And the comment at the bottom is, Pluto is kind planet. Pluto is not a planet. And you can see what the German astronomer thinks about that particular idea. And then, of course, we had the general public. Size doesn't matter, protests for Pluto. And then the diagrams, icy bally thingy, not sure really, too small to matter. What are astronomers doing in this? And then later on, what is this? We are a dwarf planet? For a person sitting on Pluto. Pluto 1930 to 2006, revolve in peace. And Pluto, proof that science matters, that size matters rather. So they were really quite cool. There's a lot more of these, but I only put a few of them up. And so many lessons were learned for astronomy in general, certainly by the IAU. So we realized that actually this is totally undemocratic altogether, except in 2006, doing anything else was actually very, very difficult. Technology hadn't really caught up to sort of e-voting by then in any sensible way. So now we do have e-voting for contentious issues. So the General Assembly will debate a particular topic, and then it will have a vote, which is just a generalized vote, and it's not a binding vote. And then it will go out to the community, to all the members, to vote on these. And recently in 2018, we had the less dramatic IAU resolution of the Hubble law being recommended and been spoken of as the Hubble-Lemaitre law. And this was voted on in the auditorium as a generic vote. And then it went out and it was overwhelming, substantiated by e-voting. So now let's go to look at the New Horizons mission, Alan Stern's mission to the outermost planet, or the dwarf planet now called Pluto. So it was launched in January 2006. So this was very new when the General Assembly was on in August. And if you'll notice on here, it's launched, it goes to the Jovian system in 2007. Then it blasts out past Pluto in July 2015 and keeps on going out to look for KBOs between 2016 and 2025. We'll talk a little bit about this later. But it zips through the whole system. It doesn't do any orbital anything else. It doesn't hang around taking photographs. It just hurtles out, just like Voyager did. And so this is the view from New Horizons on April the 9th, 2015. You can see two fuzzy blobs of Pluto and Charon. Then by June 25th, it's getting closer. You can see them distinctly together. And then you can make a montage. And this is the very important thing about Pluto and Charon. It really is a binary system. You can see the X in the center, which is the barycenter, the center of mass of the two bodies, because Charon is so large. And for all the other planets in the solar system, the center of mass of the planet and its satellites lies well inside the planet's surface or atmosphere. But for Pluto, it doesn't. Pluto itself revolves around the center of mass of the binary system. And so this is why people were really unhappy about Pluto and Charon being essentially a binary planet in terms of that. And so we move on. And then by July the 13th, 2015, we'd got closer. And here we have Pluto in close-up. And then the closest flyby in July. And then we have Charon looking pockmarked and cratered with crinkly rills in it and fabulous views. Now I'm not going to talk about the planets because that's not my topic, but they really are fabulous Kuiper Belt objects in terms of that. So as a matter of passing, HST had discovered, the Hubble Space Telescope discovered 4 moons as well as Charon going around Pluto. This is in 2011. And the HST was doing this to make sure there were no rings going around Pluto that might impact the New Horizons flyby. So in doing this, it found 4 tiny moons called Nix, Hydra, Styx, and Kerberos, all good mythologies about the underworld. But also we discovered there was an atmosphere. And this is my favorite photograph of essentially Pluto. It's a backlit photograph as New Horizons blasted past it and away. And it's got a very, very thin methane and CO2 atmosphere. It's very, very thin and tenuous, but it's a gorgeous, gorgeous backlit photograph of the atmosphere. So New Horizons kept on going and it journeyed to the TNOs and it flew by the KBO Arakoth on January the 1st, 2019. Now, Arakoth was interesting because originally NASA called it Ultima Thule, which people didn't like the name at all because of connotations of the past. And so it was renamed Arakoth, which means sky in Native American. But the interesting thing was, this is clearly 2 bodies that have collided and merged to form one. So it shows that cold collisions, which will grow, can happen in the out part of the solar system. So New Horizons is continuing to fly by, and it's now seeking a new TNO to actually go and visit. But unfortunately, there's nothing obvious, and there's a real concern that actually New Horizons might be redirected to different missions, forgetting Kuiper Belt Object, which Alan Stern is not very happy about at all. So not only didn't it get to go to see Pluto, the 9th planet, it's now not even going to go, maybe not going to see new TNOs. So this is worrying. And this might be the end of the mission. But the latest is that the NASA is still debating what to do with it. I'll ignore that entirely. So final speculation now. Is there a 9th planet out there? Mike Brown, the famous Caltech astronomer, planetary astronomer, discoverer of many, many KBOs, he still thinks so. And in 1916, he postulated and wrote a paper that there's a new 9th planet, which was 6 times the mass of the Earth and 15 times farther out than Neptune. It was based on the orbital calculations of Sedna and a few other Kuiper Belt objects. But many, in fact, I would say most people believed it didn't exist. It was all down to resonances and just hadn't got enough orbital data. Well, interestingly enough, just last month, Mike Brown and a theoretician published another paper where they refined their calculations, and they had more orbital distances and they had more data. And they now propose that there isn't a 9th planet, planet 9. It's 10 times the mass of the Earth, and it's now 20 times farther out than Neptune. So the answer is, watch this space. We just don't know. But in the future, we will certainly know because the Vera Rubin telescope will be able to detect all of these things. And if there's anything big out there, we'll find it. And I just want to finish with interesting things that pop into us from outer space. The Oumuamua interstellar visitor appeared very suddenly in 2017. This is the artist's sketch of it, although it was only a sketch, and the date which gave it that are a bit ropey, but it was a few hundred meters in size, and it hurtled through the solar system. It came in, hurtled past the sun, and hurtled back out again. This is not part of the solar system. It's not from the Oort cloud. It's coming from somewhere in interstellar space, just happened to pass in the solar system and hurtled out again. So you're never quite sure what's going to happen, but this happened very, very quickly and went very, very quickly. And so that makes us, should we worry about interstellar wanderings? Well, interestingly enough, the Gaia mission, which has charted the positions and velocities and proper motions of stars in our galaxy to a huge accuracy indeed. It particularly looked at a motion of a little red dwarf star called Gliese 710. And it worked out that, in fact, this will impact the Oort cloud, our Oort cloud, in 1.3 million years' time. Now, the Oort cloud is a bunch of, it's never been seen. It's postulated to be a few thousand AUs beyond the sun. So it's way beyond the Kuiper Belt objects. It could have big objects in it. It could be where the long period comets come from, but it's never been seen, but it's believed to exist out there. But when this Gliese 710 actually plows its way through the Oort cloud, there's also a possibility it can eject comets into the inner solar system, which then get interesting in terms of extinction level events for the Earth. So in 1.3 million years' time, we better watch this space. Thank you.
That was great, Ian. Thank you very much. Chris, if you're there, we'll hand over. You got any questions? If anybody has any questions, please pop them into the Q&A, and Chris will hand them over. Over to you, Chris.
Thanks, Pete, and thanks, Ian. That was fascinating, and loving the photographs, especially the close-ups of Pluto. Just absolutely stunning. Not many questions, so as Pete said, if anybody does have any, please feel free to chuck them in the Q&A, and I will obviously pass those on. I do have one quick one. So you mentioned about the possibility of a 9th planet, and I think as part of the presentation you mentioned, Mike Brown mentioned 10 and 11 planets. With the improvement in space telescopes like the James Webb, do you think that there will be more planets still yet to be discovered, and how's that going to affect the classification, and is it likely that that might bring Pluto back into being a normal planet, or is that always going to stay as a dwarf planet?
Interesting question. I mean, I think in terms of certainly the Vera Rubin telescope will that's an optical telescope, will discover many. James Webb has a problem in the fact it's got a very narrow field of view. So if something can position where it might be and you point the James Webb at it, then you get a very good chance of discovering a lot more about its body, its shape and size, etc. But the Vera Rubin telescope, which meant to start working in 2025, and this will just have its, I mean, it's got huge, I mean, it's got a field of view which is like 7 times the moon diameter. So it goes very, very deep very quickly. So it will map the heavens, and it will be able to measure these moving objects. And so if there is a big planet out there somewhere, I think Vera Rubin should detect it. Now, whether we'll ever change Pluto, I think the answer is no. I mean, my feeling when people ask me about that is, I said, if we discovered Pluto in 2003 or 2004, would we ever have called it a planet? And the answer is, I think we never would. We'd have called it a Kuiper Belt object or a TNO if we discovered it 2003, 2004. But because we discovered it then, we didn't know anything else. It was natural to call it a planet, which was fine. But as soon as you started looking at it and finding other things, then you got to say, well, actually, it's probably more like a Kuiper Belt object.
Thank you. So there was one other question that came through on the internal chat. Just a clarification: what is a cleared orbit?
A what orbit? Sorry, did I?
Sorry, what is a cleared orbit?
Oh, a cleared orbit. I thought it was my pronunciation. A cleared orbit is where essentially a planet has managed to be sufficiently big. It's wiped out anything else in the orbit. It's scattered things. So when it goes around the sun, it doesn't meet anything else. There's nothing else in the orbit, apart from these resonance effects, which are on the Lagrangian points, which I was unaware of until the debates happened in terms of that. But it just means the planet is big enough, has enough gravity to clear out the orbits. And the interesting question is, well, Mercury is not very big. Has it cleared out its orbit? And the answer is, well, it's so close to the sun, it has cleared out its orbit, but it's not very big. It's a very, very small planet. It's not much bigger than Pluto.
That's interesting, actually, because Rich Oakley has also put a question in that mentions Mercury. Given Pluto's size relative to Mercury, is there a chance it will be reinstated as a planet? Or conversely, based on what you've just said in your answers a couple of minutes ago, is it likely that Mercury might be classified as a dwarf planet?
No, I think neither there. I think given the fact Mercury's just safe enough to be okay. But it did make me wonder when I started plotting the sizes of these things and thought, actually, Mercury is not very big, really. It's actually quite a small body. But I think, but on the other hand, it has an orbital parameters which make it look reasonable, whereas Pluto, his orbital parameters definitely make it look different. So I think we've got where we are, where Pluto is not a planet. But I have to say, my colleagues in the solar system do not refer to small solar system bodies. They do not refer to dwarf planets. They just call them what they are. They call them asteroids and comets and things, and TNOs and KBOs. So I think the only thing the IAU has done is just demote Pluto from being a planet.
Almost like they've got a hate clause going out on Pluto. Thanks. There's no other questions that come through. If anybody does have anything else or they think of anything, please just chuck them in. And if we've got time, maybe we can ask Ian a little later on. But Ian, thanks so much again. Sorry I didn't make the meeting on Wednesday, but thanks for tonight. It's been brilliant. And I'll pass you back over to Pete and to Rich.
Thank you very much, mate. That's really good. Yeah, it's quite amazing, Ian, because I do a talk to sort of scouts and schools, and it's a tour of the solar system and beyond, explaining the size of the solar system and universe and the like. And it is still now we're now nearly 20 years on since Pluto was demoted, let's say. And when you don't mention Pluto as a planet, you still get this reaction from the kids and even the adults sometimes saying, "What about Pluto?" It really is still quite funny, I find.
Yeah, it's true. I mean, we all grew up knowing Pluto was the 9th planet. There were 9 planets in the solar system, and Pluto was the 9th. I mean, we all grew up with that. Everybody knew that.
It just goes to show the feeling for Pluto, doesn't it? It really does. Okay, Rich, are you there? And you can do.
I am here, but I've lost my video for some bizarre reason, which is a bit unfortunate. But Ian, that was an absolutely fascinating talk, and it's a very interesting study in governance of a big organization, the way the IAU, I thought, organized the vote and had a group set up to answer criticism and everything, because you just think it doesn't seem like organizations these days where they just seem to have problems and never find a resolution anymore. So so I thought it was a very interesting study in governance as much as anything, it's but anyway, Ian, that was an absolutely superb and fascinating talk, and unfortunately I've lost my video, and so I won't be able to show you this rather magnificent tumbler that we've got to send to you. So, but anyway, thank you very much. And yeah, thanks for a superb talk. And we look forward to seeing you again soon. So take care and thank you very much.
Well, thank you. Thank you all very much. I really enjoyed it.
Yeah, thanks very much for joining us again, Ian. It's a shame you lost the feed there, Rich, but if that's the only issue we're going to get tonight, I'm quite happy. Yeah, Ian, thank you so very much for giving your time for us, and it's great to see you again.
I will drop out now and go and have my gin and tonic.
Yes, I don't blame you. I think that'll probably be 3 tumblers you got now, isn't it?
Yes.
Yes. So we might have to get you up to get to make a get forward. So
actually, I went and had look in. I went and had look in the cupboard tonight, and I've already got 3.
You got 3. So that'd be a 4th. So it's the 4th time you've been.
Yeah, I thought it was the 3rd, but it must be the 4th time altogether. And I've thoroughly enjoyed it.
Good. I'm glad you enjoyed it. We certainly did. So okay, everyone, we all go and have a break now for 10 minutes. Ian, you're quite welcome to kick back with your G&T for the second half if you want to watch what's going on.
I'll go and catch up on the news, I think.
Okay, no problem. We'll let you go and do what you wish and enjoy your dram. Thank you again.
Thanks, everyone. Bye then.
Good night, Ian. Okay, everyone. So we'll go and have a quick 10-minute break, and we'll be back. What we know, 1:30. So we'll be back. Yeah, we've got plenty of time. So we'll go back about sort of 20, about 20 to 9 for the second half. Oh. Okay, welcome back, everybody, to the second half of this meeting. Right, we'll kick off now with some of the members' photos that have been sent in. I do say some of them because they're still coming in thick and fast, believe it or not. Okay, let's say we only had probably 3, maybe 4 clear nights. So I think everyone took advantage of these nights and got out there and done some imaging. So we're going to start off with Mark Betson, who's been sending in his images that he's been taking with his Dwarf 2 smart telescope. And let's say it was a cracking piece of kit this is, when we'll try and explain a bit more about this in one of the workshops and maybe even in the meeting. We'll see what we can do with this. So this is M78, Casper, the Friendly Ghost Nebula. And this is in Monoceros, I believe, just to the east of Orion. So you can just see the nebulosity. It's quite a small nebula, this one, but you can see the nebulosity there. So I can't quite see why it's called the Friendly Ghost, but maybe it's just me. It's a cracking shot there with a wonderful star field in the background. And this is the next one. I say it's his. This is a conglomeration of 10 Dwarf 2 smart telescope users who've actually combined all their images together to bring out this image of the Orion Nebula. As you can see, the more information you can take with each individual shot and stack them together, and then with some nifty processing work, you can get images like this that, well, I would say even 5, 10 years ago, definitely, we would never think we would be able to get images like this as amateur astronomers. It's Hubble sort of standard, really. It really is fantastic. And then, if anyone wants to get into astrophotography, I mean, the moon is always a good target to start off with. It's nice and big, nice and bright, and you learn a lot, to tell you the truth, especially about exposure times. But if you've done this one again, this was on the 18th of June, the first quarter waxing moon. It's absolutely fantastic detail you've got in there, Mark. Really good. And then 5 days later, when the moon filled in, we got the full moon. And I say the detail you've actually got in here. Let's say you got the crater Tycho there is one of my favorite ones to look at, actually, because the ejector rays that come off of this. What I mean by ejector rays is that when whatever it was caused that crater, the ejector came out of the crater and spread around the moon. And if you actually look from here, you can see the ejector rays going out here, down the bottom. But also, if you go up through here, you can actually see an ejector ray that is from the crater Tycho, and I believe this goes virtually half the way around the back of the moon as well. So that must have been a massive impact that caused that crater. A brilliant image there. And then I say the sun has been out, believe it or not. We wonder what the strange orange thing was in the sky, but it was the sun. And I say with the Dwarf Smart 2 telescope and the solar filters you get with the solar filters you get with it, you can actually get pictures of the sunspots. And I got a funny feeling you've actually picked up some faculae on there as well, but don't know. It could be. And what I mean by faculae is the sort of the bubbling surface of the sun. You can see all these spots around here. Here's your sunspots, obviously. But there's something in there. Maybe not. It definitely looks like it there. You got a line of it there. So well done, Mark. That was actually fantastic. Now then, Alan Tuff has been busy again. Sorry, Alan Tuff, it's been busy again. Imaging this time comet P144P, and this is it's in the star field of the Hyades. Right then, little question for you all. Get your Zoom toolbar up and click your hands up if you can make out the comet. Whilst I'm doing that, I'll just explain what you're looking at here. So the Hyades, as I say, is like the head of Taurus the bull. There's Aldebaran, the eye of the bull. And there is, as I say, like the V shape of the Hyades running around there. Oh, two people have raised their hand. Anyone else? Can you see the comet yet? You ever looked at the Hyades, something will look a little bit out of place. Oh, 6 people. Yeah, so you're doing well. So the comet itself is just there. Look, this greeny color there, because you don't very often get any green stars. Okay, so, and in the next picture, you'll also see the slight difference as well. So Alan took this, I think it's with the iTelescope from Spain. It's an online telescope that you can all log into if you want to pay a bit of money to get images like this. So this is the comet again, but as it's moved out of the Hyades, this is Aldebaran, the star, the eye of the bull. And here's the comet now down there. Now, if you look at the stars, you can see they're nice sort of pin, sharp pin points of stars. But if you look at the comet, you can actually see the comet nucleus around the side. All right. So if you're ever looking for a comet, actually in the viewfinder of a telescope, you're looking for something like that. So me and John were in the observatory, the club's observatory last night. We managed to pick up comet Pons Brooks, and it was ever so easy to find in the viewfinder, and it looked fantastic in the Williams telescope. Okay, so a couple of mine now. So I've done this actually during a full moon. It doesn't come out as brilliant as I wanted it to. As I say, I've got a little bit of light pollution coming in here, so I struggled to actually to clean it up quite as much as I wanted to. And I also couldn't use my dual band filter either, and because it was a really cold night and it kept frosting up. So this was without the dual band filter, but I put the IR pass onto it, so it took the infrared light more. So, and I've done this so on the 13th of February. It's 590 10-second images, and that's at a gain of 80. I think the gain, I could have done with put my gain down a little bit, maybe, as well. That might have helped. But this is the Rosetta Nebula, once again in Monoceros. I say, visually, you don't very often get to see the nebulosity of the Rosetta Nebula, but you can make out these 6 or 8 stars, like in a row here, quite easily in a telescope, and it really does look lovely in a telescope because there's a massive star field around here. So that's something to give a go. If you can't see the nebulosity, it's always worth having a look for the cluster of stars. This was another one I'd done the same night, say 435 images. There's 8 seconds this time, so it's not quite as grainy and noisy. And I say this is the Great Orion Nebula, which is here. And you've also got the Running Man Nebula at the top here. So that's M42 and M43. Easy to find in Orion. Definitely give it a go with a telescope, pair of binoculars even. If you haven't ever seen it, it will blow you away. That's my couple. Now we're over to Rays. I said there was a lot tonight, didn't I? Over to Rays. This is M78. So this is the Friendly Ghost Nebula again. And I'd say it's a little bit. So you can see the difference between using a 120 millimeter refractor compared to using the dwarf telescope. It's a much smaller field of view, and you actually get a bigger, a bigger view of the item you're actually imaging. Okay, so a lot more detail in that as well. Well done, Ray, for that. And say, but that was 3 hours worth of imaging to get that, and then obviously processing as well, as you can see there in Pixie Nights and adjusted in affinity, which I'm sure what Ray will be talking a little bit about on Sunday at the workshop. Another one of Ray's, the Ghost of Cassiopeia. String and nebulosity running through there. Beautiful rendition of the stars there, Ray. I really love that. Really, really nice. Once again, it's 2.5 hours of imaging time there. say it does take a while to get this detail, but it's worthwhile doing it if you ever get the chance. And finally, we've got Messier 106, a spiral galaxy, once again taken by Ray. Does he put how many hours that was? Pounds. I'm going to say 3 hours then. It must have been hit the pound sign rather than 3. Yeah, so you've got the structure you've got in this Ray is just fantastic for, you know, from your back garden. You know, the spiral arms, and I remember rightly 106. These sort of red areas are high star forming regions, very much like the Orion Nebula in our galaxy. And then you've got another small galaxy on the side there. So Ray, Alan, and Mark, thank you very much for actually sending those in, and please do keep them coming. And anyone else who's got any images, please keep them coming as well, because oh no, we haven't finished. Sorry, I do tell a lie. Then we were saying about the Rosetta Nebula, and if you take a little bit more time and a few more exposures, you can get you actually get a image like this. Let's say that is once again actually stunning, especially the trail of dark dust you can see running through there. So, yes, that is it. So as I say, if you've got any images and you want to have a go at taking any images, please do send them through. Doesn't matter how good or bad they are, give it a go. And we've all got to start somewhere. I was looking through some of my own stuff the other week, and I thought, my word, that's rubbish. But we've all got to start somewhere. It's just also another thing about technology nowadays. It just makes imaging not easy, but easier, I would say. Okay, so we'll now go over to Mick for the Moray Sky at Night.
Thanks, Pete. Okay, I'll just share my screen. Okay.
Yep, we've got all that.
Yep.
Okay, over to you, Mike.
Boundaries will be a sec. Okay, so hello and welcome to the March 2024 edition of the Moray Sky at Night. So tonight I'll start with the usual moon, planets, and then I'll move on to some things further afield. So inner planet Mercury is at a magnitude of -0.2, and that reaches greatest eastern elongation on the 24th of March. Venus is a bright magnitude -3.8, but that's closing rapidly in the sun. It may be glimpsed early in the month. Mars is similarly placed, as you can see in the morning sky here, at magnitude 1.3, going through to 1.2. Jupiter is at a magnitude of 2.2. If I go to our evening sky, I'll show you here. So that's still visible at the minute, and that's in Aries. Saturn is at a magnitude of 1 to 1.1, and that remains in Aquarius. And as you saw in the morning sky, it's right close to the sun as well. Uranus is at a magnitude of 5.8 in Aries, just here. And Neptune is at a magnitude of 8 in Pisces. So some possible photo opportunities for you through the month. We'll go to the 13th. I want to be at about 7. So 13th, we'll be able to see a crescent moon next to the west of Jupiter. On the 14th, it'll have moved just past Uranus, heading towards M45 here, the Pleiades, or the Seven Sisters. On the 15th, it'll be just to the north of Aldebaran in Taurus. Continuing through the month, on the 16th, it'll be just next to Elnath. If I can get onto it, there we go, Elnath in Auriga. Through to the 18th, so it's going to be forming a bit of a triangle with the heads of Gemini, Castor and Pollux. 21st, it'll just be to the north of Regulus. And if I go a bit later in the evening, at 10 PM on the 26th, it'll be right next to Spica in Virgo. So that's the photo opportunities this month. As far as meteor showers go, there are no meteor showers of note this month. So I'll set us back to tonight. I'll go to 11 p.m. to the south. Okay, so normally I'll give a bit of an overview of some constellations. I've been doing that regularly now, and I think there's enough videos on YouTube that everybody can catch up and watch, especially if you want an introductory one, which I will do in September again when we restart at the start of the dark nights again. But tonight I'm going to do something slightly different, and I'm going to just go for galaxies because they're nice to go and have a look at. So some galaxies appear to like company, and there's many pairs and larger groups that are worth viewing, and this is probably one of the best times of the year to go and have a look. So first I'm going to look at an amazing, although quite a challenging object, the porpoise galaxy in Hydra, the water snake. So I'll do some searches rather than trying to tell you exactly where it is, because I'll be here all night, I think. So it's in Hydra, the water snake, as I said. Here's a bit of artwork, so you can see what's going on. So it's the head of this water snake. There we go. So NGC 2936 and NGC 2937 just below it. Come on, Stellarium, play the game. Don't let me on it. Anywho, I shall continue. So they're an interacting pair of galaxies around 300 million light years away, and they're designated ARP 142, which is in the Atlas of Peculiar Galaxies by the late American astronomer Halton Arp. 2936, the Penguin Galaxy as it's labelled here, or the Porpoise Galaxy, is an irregular galaxy that's being severely distorted by the gravitational forces from interaction with the smaller yet massive elliptical galaxy NGC 2937. Over the eons, such mergings have set off furious star formation and changed 2936's disk from a normal flat spiral into the shape that, from our perspective, looks like a porpoise or a dolphin. I think the two of them look more like a penguin guarding its egg. Let's look at, oh, there we go, I can get on it now. Right, so there that's showing 2937. So due to their vast distance, both galaxies are faint and are around 13th magnitude with small apparent diameters. A 16-inch telescope, so pretty big, 400mm telescope, might be able to pick up the banana-shaped smudge at a high magnification, so it's best to try at a site free from major light pollution on a transparent night around a new moon. And this month the new moon is on the 10th, so a few nights either side of the 10th, assuming a clear sky of course, would be your best option. So on to our next target, we're going to head towards the Great Bear. Of course, Ursa Major. Oh, we're going the wrong way. No. Let me just get up here. And so I have in my notes, it's 4 degrees southwest of Thuban, which is Alpha Draconis. So here we have Draco, and this star here is Thuban. Around about here, I'll just do a search again, easier. We're NGC 5216. Oh, went a bit too much there. So these are the interacting galaxies 521, NGC 5216 and NGC 5218. There we go. and these are designated ARP-104. So they were discovered by William Herschel in 1790, and they're popularly coined Keenan's system, after a paper that was published by Philip C. Keenan describing the bridge of material back in 1935. NGC 5218 is a spiral galaxy, shining at magnitude of 11.9. Its companion 4 minutes to the south is the elliptical NGC 5216, shining at a marginally fainter magnitude of 12.5, although it has a similar apparent diameter. A 10-inch telescope should pick up the system on a transparent moonless night at a good observing site, although this bridge of material might be much more elusive. But some deep amateur images can reveal the tidal tail of gas and dust between the galaxies. So material is being stripped from NGC 5218 by its more compact neighbour. Bit of a theme going on from like the last one. So this past close encounter is believed to have taken place around 330 million years ago. Disruption to the disk's clear as well. You can see small streamers of material emanating from both galaxies. So these galaxies lie around 131 and 134.6 million light years away, and I find that when I found that out, it was quite mind-boggling to think that the distance between these two galaxies, 3.6 million light years, is actually further than the distance between us and the Andromeda galaxy that we can see in our sky. Next, we move to the whale and the hockey stick. This is in Canis. Oh, that's I think 5, 4, 6, 5. What's the other one? So NGC 4656, the hockey stick galaxy. This is to the southeast area of Canis Venatici. Put some borders. This shows your constellation boundaries, the red lines. NGC 4656 and NGC. Which have I got this the wrong way around? Yeah, 4656, the bottom one, the Kuiper galaxy. So both these galaxies are around 23 million light years away. And due to the half-degree separation, it's not that obvious that they're actually grouped and interacting. So the northerly one, 4631, NGC 4631, is slightly brighter, larger, shining at a magnitude of 9.2, with a diameter of 15 by 3.3 minutes. So that can be spotted in telescopes as small as 3-inch or 80 millimeters. Just north of the midway point, we have NGC 4627, which is a 12th magnitude elliptical galaxy, around 2.7 by 2 minutes across, but that requires a bit more aperture to see it, so we need a bigger telescope. So images show ample yet subtle evidence of the whale's interaction with the hockey stick galaxy, and it exhibits numerous reddy pink star forming regions along its length and faint wispy star trails. So just half a degree or so to the south, we find the one it's interacting with, the hockey stick galaxy. Excuse me, at a magnitude of 10.3. If you look at it through a large telescope or process sufficient image data, you'll see a splinter of light that displays a kind of hook or appendage at its northeastern edge. And planetarium programs such as this stellarium that I'm using shows it as NGC 4657, although that is not a separate galaxy, but just evidence of tidal interaction with the whale to its north. So next we're going to head south into Bernice, if that's how you pronounce it. Now this area here is very interesting. So along with the neighbouring Virgo to the south that we see here, this is galaxy heaven for deep sky observers. The Virgo cluster of galaxies, which is around 2,000 galaxies, is the most famous and accessible collection of galaxies for amateur astronomers. And as you can see, it straddles the boundary between Coma and Virgo to the south here. It's here that we'll find Markarian's chain. So if I remove some of these letters and words and zoom in a wee bit. So this bit here is a Markarian chain, and it starts here, going around to here. And right in the middle of it, we have this interacting pair of galaxies known as the eyes, or ARP 120. So we have NGC 4438 and 4435. And they're quite close as well to another pair of giant elliptical galaxies, M86 and M84. So NGC 4435, the smallest of the two, and the more northerly of the pair, is a barred lenticular shining at magnitude of 10.8 over its 3 by 2 minutes form. And just a few arc minutes to the south, brighter magnitude 10 NGC 4438 shows a lower surface brightness along its 9 by 4 minute structure, but images show it has a remarkably distorted disk and long tidal tails, signatures of strong interaction with NGC 4435, which itself hosts a population of young stars. So this pair can be seen through a 6-inch telescope with averted vision, with their apparent diameters extending up to 1.5 by 1 and 4 by 2 arc minutes, respectively, through a 10-inch telescope. So if we just move our telescope a little, 2.8 degrees to the south, here we see the Siamese twins. So NGC 4657 and NGC 4567 and 4568 are interacting Siamese twins galaxies. Recent studies have confirmed that this pair of spirals are in the process of colliding. Amateur images on moderate to very large aperture telescopes show that excuse me, the almost face-on presented pair appear to be joined together at their eastern tips, just in here. More modern telescopes, such as a 4-inch, show the pair as a single odd-shaped entity. NGC 4568, the most southerly of the pair, shines at a magnitude of 10, and that's around 4.6 by 2.1 minutes in diameter, making it noticeably larger, although marginally brighter than 4567, which is at a magnitude of 11.3 and 3 by 2.1 minutes. So lastly, in our galaxy pairs, we come down through the asterism known as I didn't know this, known as the Bowl. This is Virgo, and this area here is known as the Bowl of Virgo. So we head south into a constellation I've never mentioned before. It's a southern constellation, Corvus. But on the way, before we get there, just here on the border, just as an extra added bonus, we have the awesome Sombrero Galaxy, a magnitude of 8. That's M104. Always worth a look at. And so for the next target, the last target, sorry, I'm going to go to, so Corvus, an odd shaped, take to midnight to see a bit more of it. Here we go. Bit of an odd quadrilateral shaped asterism, a third magnitude star, so it's easy to find from the UK on a fine moonless night. Although it doesn't get very high, probably 20 degrees by 1 AM mid-month. But it'll be worth the wait if our target is the amazing antenna galaxies. So they're located 3.5 degrees southwest of Gyna, this star here. So just here we have the antenna galaxies. So they're a pair of colliding galaxies called the antenna for the streamers of stars, dust and gas stripped out from both galaxies are as a result of the violent encounter they are having. Both are rather small and similarly bright at a magnitude of 10.7, with NGC 4039 to the south slightly larger, spanning 3.2 by 2.2 minutes, as opposed to 2.6 by 1.8 for the northerly one, NGC 4038. Because of its low altitude for the UK, a 6-inch telescope shows the pair as just a fuzzy halo about 2.5 minutes across. Deep amateur images, though, can show some of the turmoil and destruction that the encounter has unleashed, including the amazing antenna. Okay, that concludes tonight's Sky Tour and for this season, so I'll see you all again later in the year. Back
Okay,
to you,
Mick.
Pete.
Thank you very much, mate. That was really, really good. A lot of work went into that to get that, getting all them together. Well done. Yeah, the galaxies. It is a favourite of mine looking at galaxies. Like you said, the distance between those two galaxies you're looking at, you think no way, and then you realise how far away they are as well. And it is the thing that got me into astronomy as a young kid was the vast distances. But okay, Mick.
Yep.
Thank you very much there. Okay, we'll finish off with a little bit of club news. Hot off the press, email from Stan Barber tonight. Now, some of you might know, some of you probably won't, but down at Moravia in Kinloss, the Aerospace Museum, there's actually a planetarium. He's actually looking for volunteers to help run the planetarium. Now, me and Mick done it and Bill done it a few years back. It is great fun, actually. It is great fun, and it's not that difficult to control, believe it or not. I would love to do it again, but I just haven't got the time at the moment. If I was retired, I would be down there at a shop most weekends and going through the planetarium. As I say, it is really, really great fun, but time is a problem. But he is looking for volunteers. If any Sigma members feel as though they could give a couple of days, it is voluntary, obviously, because they all work as volunteers down there. If you let me know, I can pass you over to Stan, and he will let you know what's involved, and obviously give you a little, sort of a training session on the planetarium. And say if you can, it would be very good, and it's also good for Sigma because it gets our name out there again. Right. Yeah. So this obviously marks our final online meeting for the year. We'll be back to our normal meetings again at Lambride sort of Community Centre from April. For any new members who's not sure where it is, there's a link in the newsletter, or you can go to our website and then get a link from there to find where the community centre is. Now the first Astro workshop, that went down really well. Ray done a fantastic job teaching us how to image the night sky and how to process those images, and some good little tips and tricks on it as well. Now the next workshop is on Sunday the 3rd, this Sunday coming up, and I say that's going to be at Lambride again at 2 p.m. This time covering the subject of imaging the solar system. We got 11 people signed, 12, maybe 13 people signed up to it so far. If you want to join, you can do via the Spond link. All the information is in there. If you're not on Spond, there's a link in the newsletter, or you can email me and I can add you onto it. So that's the next one, which is on the 3rd of March. I'm also trying to arrange another workshop on the subject of setting up a telescope, and mainly on equatorial mounts. I think I've had 10 people interested now about how to set up the telescope and set up, equatorial mounts. So I'm planning, if possible, to run that on Saturday, the 16th of March. Once again, that'll be at Lambride, but I'll confirm this once I can get on to the new Lambride Community Centre website. They should have a new online booking system on there today. If I can get that booked, once again, I'll let you all know via email, and we'll organise that through the Spond. Also, Mark Bedson, you've seen some of his wonderful images tonight that he's taken with his Dwarf 2 Smart Telescope. He's offered to do a workshop covering using the Dwarf 2. The date to this will be notified once we can find a suitable time that fits in with his very, very busy work schedule. So, Mark, if you just sort of let me know a time that would suit you, then we can get things organised for that. So all these workshops will be organised through Spond. We can't do it through email. Well, we could, but the workload will be immense. Spond is ever so easy. A lot of you are on there now, and you do actually use it. You will get a ping saying this is happening, and all you got to do at some point is click accept, you'll go, or decline. You're not going. If you're not going, do click the decline buttons. It just helps us know, engage interest. Okay. And say we always make a little small charge for these, because this is something on top of what Sigma normally has done in the past. As I say, we charge £5.50. It covers the hall costs, the actual hall costs, and also it does include some cakes and teas and coffees and that as well. So you are getting pretty good value for your money there. So we normally ask for a payment through Spond. If you can't pay through the Spond, or if you don't want to pay through Spond, I know a lot of people are a bit reluctant to pay online, which is totally understandable these days. No problem with that at all. You can pay at the event, but I've just asked, please let me know that you're coming so I can add you to the Spond list, so we know how many tables are set up at the events. All righty. So that is that. Outreach. Yeah, there's a very busy month of outreach coming up. Firstly, on Wednesday, the 6th, we're going down to Kinloss Scouts to help them with their astronomy badge. How many people have got now? Did have 6 people. We've now got 4 coming to help. That probably will be more than enough. I might get another couple of members of the committee to do it. And then also on March 23rd is the Kinloss Barracks Family Fun Day. We've been asked to go down to there as well, where hopefully we'll have some telescope displays, we'll have a solar scope going, and if I can get it organised, we'll have some rocket launching. But I went down and picked the rocket launchers up from Rich today, and there's the 2 pipes that you put the rockets onto are missing, so we'd have to see if we can get some more of those. I want to say just thank you very much to everyone who's volunteered for these, to help out at these events. We just couldn't do it without you. Yep, so don't forget, we still got telescopes for hire. We're rapidly running out of darkness now, believe it or not. I think probably got 5 good weeks left if you take out the full moon side. So if you want to hire these telescopes, it won't be the Dobsonian won't be available until after the 23rd of March anyway, because we'll need it for then, unless you want to borrow the telescope and come down and give us a hand. So to say, if you want, to hire one of the club telescopes, just let me or Rich know, and we can get that organised for you. So it's all in the newsletter anyway, so have a look through there, and there's all the links as well. the observatory, yeah, we've actually had a lot of, well, fair bit of use with the observatory over the last couple of days. Like I say, me and John were in there last night, found the comet nice and easily. John has been and used it 3 times now, and he was more than happy to sit in there. So I had a few things to sort out for tonight. I said, John, I'm going to leave you, and he was happy as a proverbial in the proverbial, and he was moving the telescope around using the dome. So just after three sessions, he's actually quite happy in there, observing the wonderful things we got in the heavens from here. So that's really and truly around about it from me, I think. So just remember that we will now be going back to live meetings at Lambride next month. I won't be there, I'm afraid. I'll be handing over to Tim to take on my bit, because I'm off to Canada to hopefully see the total solar eclipse. I say hopefully, it all depends on the weather. But also, hopefully, I'll take some photographs and send them in to you. How's that sound? So next meeting is Rich with his Anticlithra talk. Our very own Rich Oakley from Sigma, who you all know and love. He'll be there doing that, and say Tim will be handling it for you. And as I say, that was the last Sky at Night for this season. As I say, by the time we get into April, it really truly isn't dark enough unless there's some real night owls who want to go out about 12:30 at night or 1 o'clock for an hour or two until it gets light again in the morning. But Stuart will be back next month with his space news, and we're going to try a little bit more in the space news, try and concentrate more on the things that are happening astronomically rather than spaceflight wise. There'll be a bit of spaceflight in there. There's always something interesting, as you know, the lunar landing last week that didn't quite go to plan, but that's spaceflight for you. So with that, it just leaves me to thank Ian for his fantastic talk, wonderful talk, and nice to know that Pluto's still there and still in people's minds, as I know it is. Chris for handling the Q&As. Rich for doing your vote of thanks there, as you always do, very well. And Mick for your Sky at Night, and for all you good people out there for coming along and joining us. It'd be lonely if we sat here on our own. So with that, thank you all very much. Good night, and keep looking up.